This is a discussion of the Sydney Bridge toll question. If you haven't already done so, you should read the question and attempt to write out your own answer. Let's start. The question states, in June 2002, the toll for using the Sydney Harbour Bridge tunnel was increased. In the first 2 months of the new toll charge, bridge traffic fell by 12%, while toll revenue increased by 40% because of the higher tolls. We're asked what was the approximate price elasticity of demand for using the Sydney Bridge tunnel in mid-2002. Note, this is quite a difficult question, and your algebra will have to be good to follow the answer. I'll go through it quickly, but you should probably have write out your own answer and work out the algebra properly. If the price, which equals the bridge tunnel toll, increased by delta P, and as a consequence the bridge tunnel traffic decreased by delta Q, then the total toll revenue, TR, will change by delta TR. In other words, we can write, since total revenue equals P by Q, then total revenue plus the increase in total revenue, or the change in total revenue, is P plus the change in price multiplied by Q plus the change in quantity demanded. If we divide both sides by total revenue, so on the left-hand side we're dividing the left-hand side of the equation by TR, and on the right-hand side we're dividing by P multiplied by Q, which is exactly the same as total revenue, then we haven't changed anything with our equation. If we then divide through the terms inside the brackets by what's in the denominator, we find on the left-hand side we get 1 plus the change in total revenue divided by total revenue equals, and the first term we divide through by P, and we get 1 plus delta P on P, and we divide the second term through by Q, and we get 1 plus delta Q on Q. Now, delta TR on TR is the proportional change in total revenue. Delta P on P is the proportional change in price, and delta Q on Q is the proportional change in quantity. With a little bit of algebra now, we can write 1 plus the proportional change in price equals 1 plus the proportional change in total revenue divided by I'll say it again. We now have 1 plus the proportional change in price equals, open bracket, 1 plus the proportional change in total revenue, close bracket, divided by 1 plus the proportional change in quantity. The proportional changes are simply percentages written as decimals. We're informed that the proportional change in total revenue is equal to 0.4, that is 40%, and the proportional change in quantity was a negative 0.12, which is 12% when you express it as a percentage. Therefore, putting those percentages into our equation, we can find that 1 plus the proportional change in price is equal to 1.4, because it was a positive change in total revenue, divided by 0.88. That's because the change in quantity was negative. When we work that out, we find the proportional change in price is equal to 1.4 divided by 0.88 minus 1. When you do the arithmetic, you find that equal to 0.5909, or you could probably write that as 0.59. That is, the percentage change in price is equal to 59.1%. We're now in a position to work out the price elasticity of demand, which is the percentage change in quantity demanded, in our case negative 12%, divided by the corresponding percentage change in price, which was 59.1%. When you do the arithmetic, that equals negative 0.2031, ceteris paribus. That answers our question. So, the price elasticity of demand for using the Harbour Bridge tunnel is estimated to be negative 0.2031. this is quite inelastic, as we might expect, because it's a relatively short amount of time over which to measure the response to the change in the toll. This concludes the discussion of the Sydney Bridge toll question. If you haven't already done so, you should write the answer in your own words.